Hello and welcome to my Tech Fun. My name is Igor, and if you are not new on this channel, you probably noticed it is mostly about 3D printing, and I have experience now with the several types of the printers. And you probably saw the title. I decided to find what is the best cheap 3D printer now on the market. Nothing special about it. I have my list of priorities, and I was searching for a cheap printer which has this specification. For example, one of the first is the direct drive extruder, not the Bowden type. It must have TMC, those silent stepper motor drivers, because I don't even want to test those old stepper motor drivers. They create so high frequency sound that it's really annoying for me. It must have two screw lid on Z-axis, because mostly I print technical parts, and only with these two screws on Z-axis I can be sure that moving is parallel with the bed, and I will get, if I print higher objects, I will get a 90-degree angle between horizontal and vertical surfaces. I had some bad experience with printers which has only one screw. I prefer smooth rod and linear ball bearings. But usually I notice that these cheese printers are mostly with the V-slot and wheels. And of course it must be able to print PLA and PETG, and this means it must have a heated bed which must be heated up to 75, maybe 80 degrees for PETG, and also the nozzle must be able to melt the filament on 250 degrees Celsius. So I was starting on Amazon, and I found one printer from not so popular company, so-called Mingda, and this is Mingda D2. I bought this printer, but previously I was in communication with the company, and I got 85% discount for it in exchange for the review. But my opinion and review is completely independent from this, so we'll see. I will provide you the facts, and you will see the results of the printing. At this moment I'm not even sure what will be the final results. It has good parameters and specifications, but we will see at the end. So first let's go quickly the main parameters and the specifications of this printer. This is the official website for the Mingda, and let's see the product. This is the D2 I have here. And of course, first important parameters is the size, 73 by 73 by 26 centimeters. And here you can see some other important details. Most important is it has filament sensor, direct drive extruder limit switches, dual screw on Z-axis, and a touch screen. And of course it has new stepper motor drivers, heated bed, and it is able to print flexible filaments. A link to this page you can find in the description so you can read yourself. So let's see what's in the box. It has very good packaging, and first this is the printing surface, and magnetic, and it's removable. Then you have this box with some basic tools. This is the main frame with the stepper motor drivers on it. This is the power cable. This is the direct drive extruder with the hot end, and it is already attached to the base. This is the spool holder. This is one screw. I couldn't find its source. And this is the base with the bed. And that's it. And this was the content of the box. So I have the base with the direct drive extruder and the hot end. It looks like it's used. I hope it's because it was tested. Because I can see some plastic here from the nozzle. And I have this frame, cable, probably this is the spool holder, and there are some tools, cables, card reader, cable, pliers, bolts, some testing PLA, Allen wrench, and a spatula. and I can see no manual, so probably I hope it's on the card, or maybe I can download from the website. So I have to check on my computer first before I continue. Well, first we have the Cura folder. I didn't know there is a version 15. Here is a quick animation how to install it. And of course this is 1.5 one. Then we have some G-codes as examples. Then other folder with the G-codes. But these are very long printings. And we have some sample STL files, but there is no manual. So I go to the website to find to download the manual there. Download from the SD card. Let's find the D2. And yes, there is again some G-code, STL files, USB driver, Wi-Fi settings, instructions, and here is the manual. But I noticed, unfortunately, this manual is not exactly for this printer. You will see later. There is small differences, but assembling is very simple, so I didn't have that problem. So I copied the file to my phone, and this is it. So this is the general list, and look at this. This is the device installation, and then we are going to the cable connection. So only one page to assemble this printer. It will be very easy. I just have to attach this frame to the base and to mount the spool holder. But with every printer, it is very important to check all the main bolts which connects the main parts of the screw. And also with this type, always check the wheels. So this is the moving of the y-axis, and it moves on these two auto extrusions. And I hope you can see there are wheels on two sides, here and here. And these V-slot wheels can be adjusted. Just in case, if they are not tight, if you notice any movement of the bed, use the open-end wrench and rotate this hexagonal nut until you feel it is tight and it doesn't move at all. But of course the moving must be smooth, so don't over-tight it. And of course when I assemble the frame I will check these wheels too, just in case. And as always with the assembled or pre-assembled 3D printers, I always start to checking the main screws and bolts. And then the first step is to mount the frame. And for this I will use this T-holder, which is not included in my manual. Two shorter screws I use to bottom two holes and a longer one to upper, but don't tie them yet. And same to mount the T-holder from the other side, and then these two screws from the bottom has to be tied correctly because they will hold the frame in the place. It's a little bit hard, you have to balance it on the Allen key, but it's not complicated. This is how it looks like. And then on the other side, be careful, don't place it on the cable, put something below the printer at the end so you don't press the cable. I here use the hammer. And mount those two screws from the other side. And then tie these screws on the T-holder from the side. And now the spool holder, which is again a little bit different than in the manual. But of course nothing complicated about it. Not equal. You have to mount these nuts in the same direction to place into slot, and then you have to tighten them, and they have to be rotated in 90 degrees, like here. And then mount the cables. Start with the Z-axis stepper motors. And this is the limit switch for the Z-axis. But be careful to cable not be in the way of the button. Then this is the power cable. This is the limit switch for the x-axis. And then the cable for the stepper motor. And then you will need a screwdriver, which is not included, but nothing special about it, to mount this cover for the X stepper motor. And then mounting the extruder and the hot end, it has to be tied with the 3 screws from behind. Start with first one, and then you can tie the other 2. And check the movement. This is just a cover, so don't worry about this. This has to be tight. It's time to check the wheels, and I notice, look at this. So definitely this is not tight. Of course, I cannot tie this one, because this is fixed wheel, but from the other side. One important thing I want to check, that when the Z-axis moves down and the button is pressed, the limit switch is pressed, the nozzle doesn't hit the bed. So I will move manually by rotating these 2 screws. And now limit switch is pressed, and I have approximately 4 or 5 millimeters between nozzle and the bed, so it's safe. Because with the homing it will go down until it hits press the limit switch. Now we have to be sure that horizontal alloy extrusion is parallel with the base. And for this I'm using the milling parallels. For this you can use Lego blocks or domino. Just find 2 rectangular objects with the same length. I'm sure that this extrusion is now parallel with the base. And this is how it looks like assembled. This is from the right side, and this is from the left side. And it's time to turn on the power. But don't forget to check the voltage from the below. Is it set correctly for your country? Beautiful touch display, but it will be better when I remove the cover later. And then I have to check does it move correctly, so separately X, Y and Z axis. And then I can check the homing. First the X-axis, now it press the push button. And the Y-axis, but I noticed actually that wheel will press the push button, limit switch on Y-axis, which I don't know, it's good solution. And then the Z-axis, so this will press the push button, and we already checked that nozzle will stop 5 or 6 millimeters from the bed. And now very important moment in assembling. It's a very nice feature that it has that LED next to the nozzle, and in the menu we should change the color of the LED or turn on and off, but this part doesn't work, unfortunately. It just makes the rainbow colors. I hope this will be enough, at least for the test prints. But theoretically we have run out sensor for the filament. It's time to preheat the nozzle and then insert the filament. Cut the end to be sharp, because it will be easier to place into filament sensor and later into extruder. You can do it completely manually if you press this small holder here, or you can insert it a little bit and then you can use the extrude button from the menu. Push it slightly and you will see the filament on the other side. It's time for bed leveling. Let's go to menu, home position. So the Z is in home position, and now I can move it only X and Y axis, so Z must be here. And I will use just simple paper to check the position. Next is to place the nozzle above this screw. Because bed leveling means making the bed surface parallel with the moving path of the nozzle. Now I have to move this knob until I get some friction between the nozzle and the paper. And we have to repeat this procedure above every screw. So this is the second corner, again exactly above the screw. This is the third corner and the fourth one. And you have to repeat this until you get the same friction in all four corners, and then finally check in the center, and we are done. And for first printing I always choose some G-code from the SD card, because if there is any problem I know it is not cased by slicer. And I chose this vase. It is more than 3 hours of printing with 0.1mm layer height, which is I think too small. It will be better to have something for faster printing, especially for the new users. 83%. And if it runs out from the filament, which I get as a sample, at least I can check the filament sensor. If not, of course I will test it later. Now on the top I noticed these seams, and I know exactly what is the problem. The layer doesn't have time to cool down, so I slowed down the printing and I just mark it to check am I right, and from this that was finished correctly. Okay, it sticks good, so I don't have to worry that it will pop off with some other printing, so not bad. I'll wait to cool down and then I'll try to remove it. I'm not sure why it moved there, usually it should come out. Only unfortunately the raft was stick to object very strongly. I was afraid that I will break the vase, so I left it on it so far. There is a mark where I slow down the printer, so until that you can see those seals here. Not bad, but I'm not sure these waves are they part of the design. But when they are at the same size as the pitch size of the screw on the Z-axis, it is suspicious. So I have to check that. I think I found the problem, but I'm not sure how to solve it yet. So the left screw on the Z-axis looks very thick. I wasn't sure was it a shaft or the coupling or the screw lid is maybe bent. So the shaft is good. Completely off center. Or this, or this. I finally figure out what is the problem, because I take down the screw and it is straight, so there is no problem with it. Shaft is straight, also that is not problem. The stepper motor is mounted under the angle because these brackets are not mounted correctly. If you can see one of those nuts which goes into aluminum didn't rotate, and it's under the angle. Motor can be fixed with these two screws, and I hope I can move this a little bit so maybe align this line here. And now tie these two bolts. So I printed this vase again with 0.1mm layer height, again 3 hours of printing, and the result was better but still not perfect, so probably in the future I have to disassemble the other Z-axis screw to check what is the situation there. Much better, but not perfect. And it is time to test the slicing software. I already had the Cura, only had to add a new printer. I just give it the name Mingda D2. In next step I change the printing volume 230 by 260 millimeters, and it has a heated bed. And in the extruder I changed the diameter 1.75 millimeters. And then I am inserting the profile which is provided on the SD card. It's a Cura folder, it's PLA+. So this is some kind of base and I will modify this later. I have to activate this profile. And of course first two prints are the calibration cube and the benchy. Let's test the resume after power off function. Continue prints, confirm, goes to the 0 probably. Heating up the nozzle. Smart. It's extruding now, probably it will stick here, so it's not on the nozzle. Yes, good solution. And now let's see what happens if the filament runs out. So the sensor will detect the missing filament. Filament run out and it will stop the printing. So it works. Nozzle parked, and then we can replace the filament or add new. And before we click the Resume Printing button, we can replace the filament, but only manually. There is not such an option in the menu. I reprinted this calibration cube and it came out quite good, but those waves on Z-axis are still visible. And of course the next print is the benchy, but I rotated the object so that overhang will be on the left side, because from that side it gets the cooling, which is not perfect. Even on the official Mingda Facebook page they provided the STL, so we can reprint this cooling duct and to replace this original one. And the benchy came out really good. The overhang, the bridging are perfect, absolutely no stringing. The only problem I can see are those waves on the Z-axis on this big surface, but beside that, this is perfect benchy. I have issue only with one surface on this calibration cube, and that's the waves on Z-axis. But the accuracy in all three axes is almost perfect, so below 0.1 mm of accuracy. Flex filament 98A, so it's not the softest, but it's flexible. And of course, since this is the printer with direct drive extruder, I have to try the flex filament, and I decided to print some kind of corner guard for my youngest daughter. Everything started perfectly without any problem. I insert the filament. At the beginning, sensor recognized the filament. And I just want to mention how quiet this printer is. And it's super quiet. And after 10 seconds I heard the beep sound and the printing stopped. Wow, I get filament run out and I can see sensor don't see the filament. No. But after this filament runout warning message, I clicked the resume printing and it continued the printing, but from that moment the filament sensor wasn't active anymore. Anyway, it was hard start, but the rest of the printing was perfect. This looks fantastic. Only that's the old stringing, but let's see, will it come down easily? Yes. Oh, I was afraid how hard will it be to take it off, but and look at this, it's flexible filament. There was the problem with runaway filament at the beginning, but this surface is fantastic, better than PLA so far. Only here you can see some stringing because nozzle moved from this side to this side, but that's nothing, it's easy to remove. It's not super soft, but it's much better than this hardwood. It's time to test PETG. Hmm, 52 millimeters, 50 millimeters. After a short coffee break, I decided that I need a new spool holder very quickly, so I sacrificed this M16 bolt. So I drill and tap M5 thread in it, and it will hold the spools with a small diameter. I know, shame on me, I should solve this with 3D printing, but this was faster now. I just started PETG printing and again filament ran out. Continue the work correctly, but something wrong with the filament sensor. Now the LED doesn't, it's not on, so it doesn't see the filament. Of course, printing can be done even without that sensor, so I finished the printing without any other problems. Little more stringing here at the end. Let's test its accuracy. This is left hand thread. And this is right hand thread. And one more thing I want to check, when it cools down a little bit, how easy will be to remove the PETG from this bed surface. Good. It's a very good method to test the accuracy is to print some threads, especially these tricky threads. Maybe I'll show them in one of my next videos. Now let's see what is with this sensor. If I remove it, and let's try again with this filament which was provided with the printer. Oops. So when the retraction happens, it loses the contact. I posted a question in the Mingda Facebook group, and it looks like this error is not too common, so it happens only to me so far. Okay, not a big deal. I bent that small plate a little bit and that solved the problem. And now it works good. Okay, my final thoughts are really mixed a little bit, so I will start what I didn't like with this 3D printer. I had that feeling that software is not really finished. Small details, but something like LED settings or automatic power off function didn't work. And also it would be good to have a dedicated menu point where we can change the filament during the printing. So when we press it, the extruder goes to the position and holds the temperature until we unload and load the filament, and then resume the printing. These kind of things can be solved with the firmware update if they will be provided. On my SD card I didn't have the user manual, and so I downloaded it from the website, but that user manual was for a little bit different printer, not for this one. Not big deal because it's almost assembled, but these kind of things can be solved very easily. About the hardware. It's completely normal that a user has to check and tighten the wheels in the V-slot, but with assembled printers, screw leads has to be mounted correctly. Good news is that actually if the shaft is not bended and the screw is straight, then only with 4 screws we can do it ourselves, but pay attention that 2 axes are centered and parallel with these vertical extrusions. Do I recommend this printer? If you are ready to do some DIY hacks if necessary, then definitely yes. Because with less than $300 you will get a direct drive extruder which is able to print not only PLA and PETG but also a flex filament, and I really got fantastic results with it. And very important feature of this printer that it is super quiet, so even the fans are so quiet that definitely it goes up into my working room next to the Prusa printer, because I can work next to it during the printing. That was my experience. You can write me your opinion in the comment sections. Thank you for watching and happy printing!